Gats from Hungary from the Széchenyi István Secondary School, and now I'm going to present you a tool which is designed to save noise, energy and electronic junk by restructuring the cooling of the high-performance desktop personal computers. And this tool is Fairchild fan controlling system.
If we have a high-performance PC and we don't want it to be unnecessarily noisy while it isn't loaded, we need to control the fans so in an air cooling, so in a liquid cooling system. But why do we need Fairchild? Why is Fairchild the best solution for us? There are a lot of implementations for fan controlling. Let's see the deficiencies of these. The most abused solution is the motherboard fan control, but here aren't too much available outputs, as well as the load capacity is low, and in case of overload, one of the most important hardware can be damaged. Another opportunity is using hardware designed by registered brands especially for fan controlling. The analog implementations need continuous supervision by the user, so these are not real controllers. The digital solutions are better, but they also can query the data of built-in temperature sensors, and they also can control the fans connected to the hardware of the PC. Furthermore, they are unrealistically expensive. And now let's make the world a better place. The Fairchild system consists of two main parts. One of them is the control software running on the PC that queries the data from the built-in temperature sensors and defines each output speed according to user parameters. Then these values are sent to the built-in fans. And if we use the specially designed additional target hardware, speeds will be sent to it too via USB. With the target hardware we can control a lot more fans. It's useful when we don't have enough fan connectors in our PC. The system controls computer cooling automatically by the accurate temperature data without the disadvantages of the already existing solutions, but using all of their advantages. It has a lot of safety functions to avoid the overheating or damaging the PC, and does all of this without user intervention. Now I'm going to demonstrate how the control logic works. We can create control lists. In a control list we can select a built-in temperature sensor. Now I select an emulated one for the presentation instead of a real sensor. Here we can select the internal fans and the channels of the target hardware. On these slides we can set the speed of the selected channels at the corresponding temperature. We can give a name to the control list, save it, and then activate it. If I adjust the speed of the selected emulated sensor, we can see that the fan speeds change in this list and on the target hardware. If we have multiple control lists for the same channel, the highest speed will be the relevant one at the current moment. The possibility of creating alerts is a very useful function as well. We can select a sensor and set a border. When the chosen temperature sensor reaches this border, the software can display a given message even with sounds.
Szélcsendriasztás folyamatban. Szélcsendriasztás folyamatban. Szélcsendriasztás folyamatban.
In an alert, we can set scheduled sleep, hibernate, shutdown or restart. In case of sleep or hibernate, there is a possibility of waking up our computer after a given delay. It's especially useful when we leave the computer alone while it's doing a task that requires long time and great computing performance, like for example rendering of a video. If the maximum cooling capacity is not enough to keep the appropriate temperatures of the hardware, the computer sleeps or hibernates. After cooling down, it wakes up and goes on with its task until it becomes necessary to have a break again. This way we can make sure that our computer will not get overheated and still it will do its job. We can connect optional safety temperature sensors to the target hardware and we can set borders to them. If either of the thermometers reaches the border, the target hardware will override the fan speeds, sets all the fans connected to it to maximal speed and gives alarm with the buzzer. This will save our PC if the user stops the control software or the operating system can't boot. When we turn on the computer, the target hardware doesn't know at what speeds it should spin the fans, so we can set startup fan speeds. The target hardware will keep the fans connected to it on their speeds until it gets a sign from the control software. In the control software there is an adjustable hysteresis, so we can avoid the disturbing jumping of the fans between two speeds. To avoid the coarse speed changing, the target hardware adjusts the fan speeds gradual after it gets the new fan speeds from the control software. This way a single speed changing will be soft and it isn't necessary to send data frequently, so we save computing performance on the PC. The control software updates itself automatically via internet. The errors in the USB connection are handled by the controller, but in case of lasting failure, the control software displays a message to the user. This version of the target hardware fits to a standard HDD slot, but there is a PCB design of the target hardware that we can put in a PCI or a PCIe slot, like for example a sound card. Sergeant has an importance in environmental protection too because it operates fans or pumps just at a required rate. This way it saves noise, energy and attrition while keeping the temperature of each hardware at an appropriate level. This means longer lifetime for the PC and less electronic junk. So we save noise, energy and electronic litter. Thank you for your attention.